Hi guys, good morning. Good morning all. Online students, is my voice is loud and clear? Online students, could you please confirm? Okay. So in the last class, we are discussing about the how to calculate the probability by using the G-scores, and we also calculated how to calculate in terms of different values. Okay. Now, in today's class, we are going to have the next one called as central limit theorem and confidence interval. Okay. Along with this, we are also going to discuss bivariate measures called as covariance and correlation. Okay. So before moving to the central limit theorem and confidence interval, first let us complete the covariance and correlation. Now we are having the different types of measures. In that, first one is called as univariate measures, and the second one is called as bivariate, and next one is called as multivariate. So here we are having first one is called univariate measures. Univariate measures. What is meant by univariate measures? What are the measures you are calculating on a single variable? Measures on a single column. By considering a single column, measures calculated based on a single column. Okay, measures calculated based on a single column are called as univariate measures. Any measures calculated based on the two columns. Measures calculated based on the any two columns based on by considering calculated by considering any two columns at a time. It is called as bivariate measures. They are called as bivariate measures. Means they are considered on the two columns. Two variables you have to take. Variate means variable. So here you have to write instead of columns variables by considering two variables or by considering the single variable. Variable means column. Multivariate. What is multivariate means? Where you are going to apply multivariate. Multivariate measures are nothing but measures calculated by considering more than two variables. By considering more than two variables, greater than two variables at a time. More than two variables at a time. Okay. So if you are considering a single variable means univariate. If you are considering two variables at a time means bivariate. If you are considering multiple variables at a time means it is multivariate measures. Okay. So we are having the different types of measures in this way. Okay. Done. Now coming to the next point, which is we have covered univariate measures like mean, median, mode. So these are all calculated on a single column. By giving one column, we calculated. So standard deviation, variance, and calculating percentile, quartiles, IQR, all these things, including the skewness, everything are calculated on a single column at a time. Till now, whatever we have done is univariate measures. Now, whatever we are going to do is called as bivariate measures. Now, coming to the bivariate measures, at a time we have to consider two columns. What are the bivariate measures we are having is one is called as covariance and second one is called as correlation. Covariance and correlation. These are the two measures. One is covariance and second one is correlation. Now, first let us start with the covariance. Now, what is meant by covariance means variance between two variables. How much the variance between the two variables. One is impacted on the others. How much one variance is impacted on the other variance. Okay, which is called as covariance. It measures. So covariance is used for two continuous variables and it is represented COV of x comma y And it is what is the importance of covariance means it identifies the variation between the two variables. Variance between two variables means, let me explain with a simple example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the two columns, X and Y. Okay. Now, here I'll have some variance. Here also I'll have some variance individually. Variance means individually. So here, how much the variance of one variable with respect to other variable means it is more or it is less. For example, here 16, 28, something you are having. Now what happens? It is going to have more variance of y when compared to variance of x. You are saying that variance of y is more when compared to is what is that? No, see that one only tells the covariance. Covariance means by considering two variables at a time, how much the variance of one variable is impacted on the other variable. So let us take an example. How it is calculated means if you want to calculate the variance of x, what is the formula is sigma of x minus x bar whole square divided by n minus 1 if it is sample variance. If it is sample variance. Okay. Now sigma of x minus x bar whole square into n minus 1. How you are going to calculate this one means x minus x bar. First you will calculate this one. After that you are going to calculate x minus x bar whole square and you'll get the values of each and every row and you are going to do the sum of that. What are the values are there? You are going to do the sum of that. This is the way which we are going to measure. Now, how we are going to calculate the covariance means here we are going to calculate the covariance. So here, for example purpose, I'm changing the number instead of 10. I'm considering a different number so that I want to show you the difference. 13, 21, 30, 30 and 15. Okay. Now, how to calculate the covariance means first you have to calculate x minus x bar. So first x bar, what is x bar? 3. X minus x bar. What is x minus x bar means 1 minus 3, minus 2, minus 1, 0, 1, 2. After that, you are going to calculate y minus y bar, or first you complete the x minus x bar whole square only. Let us calculate x minus x bar whole square, that is 4, 1, 0, 1, 4. Sum of x minus x bar whole square, which is nothing but 10. Keep this one side. Similarly, y minus y bar. First, let us calculate y bar. That is 13, 21, 30, 45. 45 divided by 5, which is 9. So 6 minus 9, minus 3. 7 minus 9, minus 2, minus 1, 0, plus 6. Right? Now, y minus y bar whole square, which is 9, 4, 1, 0, 36. Right? Now, what is the sum? Sum of y minus y bar whole square, which is equal to 50. Now, I'm going to calculate x minus x bar into y minus y bar. That is minus 2 into minus 3. That is plus 6. Minus 1 into minus 2. Plus 2. 0 into minus 1. 0. 1 into 0. 0. 2 into 6. 12. So sum of x minus x bar into y minus y bar. For this column, what is the sum I'm going to get is 20. Okay. Take a note of all this. This example, take a note. Same thing we can see in the Python also. Whatever the answer you are going to get here in the Python also, answer should be the same. Let us cross check whether we are able to get the same answer or different answer. Completed? Now, first let us start with the variance of x. What is variance of x means? Sigma of x minus x bar whole square divided by n minus 1, that is 10 divided by 4, which is 2.5. Similarly, we'll calculate the variance of y. What is the formula of variance of y? Means sigma of y minus y bar whole square divided by n minus 1. That is nothing but 50 divided by 4, which is nothing but 12.5. Next, we are going to calculate the covariance of x comma y. Now, what is covariance formula? Means instead of considering x minus x bar, first you will calculate x minus x bar. Now, let us focus here. Just stop writing for 1 minute. X minus x bar is there now. Instead of multiplying one more time with x minus x bar, for calculating variance of x, what we have to do is with the same variable we have to multiply. Instead of multiplying with the same variable one more time, we are multiplying with the second variable, that is x minus x bar into y minus y bar. Okay, and sum divided by n minus 1 common. Just instead of multiplying 2 times into x minus x bar into x minus x bar, if you multiply with the same variable 2 times, it is called as variance. If you consider 2 variables, it is called as covariance. Okay, sigma of x minus x bar into y minus y bar divided by n minus 1, that is in this case it is 20 divided by 5 minus 1 is 4, which is 5. This is the covariance. Variance of x, variance of y, and covariance of x comma y. Clear? Which one? Covariance of here for variance of x. How you are going to calculate variance of x means x minus x bar whole square. Whole square means what? Again, you are multiplying with x minus x bar only now. What is meaning of x minus x bar whole square? What is the meaning of this? X minus x bar into again x minus x bar only, right? So here you are multiplying variance of x is nothing but x minus x bar into x minus x bar. What are the total? You are having the total, you are applying the sum. Instead of multiplying with x minus x bar, you are multiplying with the y minus y bar. Is the point is clear now? Yeah, we'll see. First we'll see the calculation and how to execute in the Python, and from there we'll move on to that. Everything one by one. Done? Completed, guys? This is calculation of covariance. Now, let us get into this covariance. So everyone has calculated now this table. Now, in the Python, what happens means the moment you give the covariance, it is going to give as a matrix. The output is going to be the matrix, where you are going to get a matrix of how many variables are there? 2 variables are there. So since 2 variables are there, you are going to get a matrix of 2 by 2. 3 variables are there means 3 by 3. 10 variables are there means 10 by 10. 20 variables are there means 20 by 20. Okay, how many variables are there? That many. On x-axis, you are going to consider the variables. Okay, 2 sides you have to take the variables. This is the first one is covariance of x comma x. Because here x is there, here also x is there. Covariance of x comma x is nothing but variance of x. How covariance of x comma x will be variance of x means you are multiplying x minus x bar into again x minus x bar, which is nothing but variance formula. What you are going to get the value? 2.5. In this case, it is 2.5. What is this one? Covariance of x comma y. What is x comma y? X minus x bar into y minus y bar, which divided by n minus 1. In this example, it is 5. Now, this is covariance of y comma x. What is meant by y comma x means y minus y bar into x minus x bar. First, you are going to calculate y minus y bar, followed by into x minus x bar. Again, you are going to do the sum. X minus X bar into Y minus Y bar or Y minus Y bar into X minus X bar, answer will be the same. So which is nothing but covariance of X comma Y, which is 5 only. For this one also it is 5. And this is covariance of Y comma Y. What is covariance of Y comma Y? Means multiplying Y minus Y bar into again Y minus Y bar, which is nothing but variance of Y, which is 12.5. So for this example, you are going to get on the diagonal values are going to be the variance values, and upper triangle matrix and lower triangle matrix will be the same. So if I take the same example here, whatever the example I have taken just now, I'm creating the same data frame 6, 7, 8, 9 and 15, right? Whatever the number I have taken is 15. Now for the 15, okay, for this I'm going to apply the covariance. What are the covariance is there? I'm just applying the covariance. Can you see? This is the variance of X, variance, covariance of X comma Y, covariance of Y comma X, and variance of Y. Why you got this matrix is clear now? Now, sir, bivariate measures means you told that we have to consider 2 columns. For example, in the given data set, we are having 3 columns, X comma Y and Z. 3 columns are there. Now, how to calculate covariance? Covariance cannot be calculated on the multiple variables. It can be calculated at a time by considering 2 variables. So either you have to consider, so for example, if 3 variables are there like this, X, Y, Z, X, Y, Z, you have to create a 3 by 3 matrix. You have to create a 3 by 3 matrix. In the first one, we have to write the variance of X. Okay, if whenever you are having the 3 variables, let me write the example clearly. Whenever you are having 3 variables or 4 variables or 10 variables or 20 variables, logic will remain same. First, you are going to take a matrix. How many variables are there? Write the same variable name here. Okay, this is the matrix. We call it as covariance matrix, out of which first one will be the covariance of X comma X. What is the formula of covariance of X comma X? How to calculate X minus X and X means first you have to calculate X minus X bar. What are the column you have got? For the same column, again, you have to multiply with one more time X minus X bar. That is nothing but X minus X bar whole square. Okay. So this, again, you are going to do the sum divided by N minus 1, which is nothing but variance formula. This is nothing but variance of X. Right. Now, coming to the next one is, what is the next one is? Covariance of X comma Y, followed by covariance of X comma Z. This is covariance of X comma Y. This is covariance of X comma Z. This is covariance of Y comma X. Y comma X is nothing but X comma Y. Both are same. Okay, which is nothing but covariance of X comma Y. What is this one? Variance of Y, because covariance of Y comma Y means variance of Y. This is covariance of Y comma Z. This is covariance of Z comma X, which is nothing but covariance of X comma Z. And this is covariance of Z comma Y, which is nothing but covariance of Y comma Z. And this is nothing but variance of Z. So your diagonal values are going to be the variance values, and upper triangle and lower triangle will be the same. Diagonal values should be variance values. Is the point is clear now? This is the covariance. Now, what is the range of covariance? Covariance can be even minus also. Minus also. Sir, how it is possible, sir? When you are multiplying two things, how it is possible? Let us take like this. You are having X minus X bar as negative value, Y minus Y bar as positive value. Then X minus X bar into Y minus Y bar, you may get negative also. If you take X minus X bar whole square, positive only, there is no other option. Variance cannot be negative. Variance cannot be negative because X minus X bar whole square, you can't get the negative values. None of the record will be negative. Automatically, some also cannot be negative. 100% it has to be positive only. The numerator cannot be never negative. But in the covariance, the numerator can be negative. So what is the range? What is the range of variance? Range of variance is equal to, you are having from 0 to infinity. Positive numbers, any number can be there, 0 to infinity. Why? What is the reason? Sigma of x minus x bar whole square divided by n minus 1. The numerator can never be the negative and denominator also can never be the negative because count is always positive only. So automatically this is going to be the positive number. Never you can get the negative in the numerator. So obviously the variance range is 0 to infinity. Least case, you may get deviations as all the deviations as 0 and in that no variance. Sir, example 1, 1, 1. If you take like this, what is average value? What is average value of this? 1 only. What is the x minus x bar? 0, 0, 0. Now, what is the x minus x bar whole square? 0, 0, 0. What is the total? 0. If all the values are same, variance is not there now. No deviation now. Everything is same only now. Everything is same means from where you will get the deviation. At least one number is different means you will get a small deviation, 0.0 something you will get. Here nothing deviation is there means 0. So there is a possibility when all the numbers are same, in that case only the variance will be 0. If one number is slightly different also, gap will be there. That gap only we call it as deviation. Right? So this is the range of. Now coming to the range of covariance. In the similar way, what is the range of covariance? Sigma of x minus x bar into y minus y bar whole square divided by n minus 1. Numerator, it can be positive. Then in that case, you are going to get the positive. It can be even negative also. Numerator can be even negative also. Divide by positive number. Automatically the output will be negative. So you may get positive, you may get negative. Both are possible. When both are possible, then what is going to be the range means? The range of covariance will be from minus infinity to plus infinity. Okay, is the point is clear? When there is a possibility of negative values, when there is a possibility of negative values, the range is going to be between minus infinity to plus infinity. Is the point is clear? It tells how much variation is there when compared to first one to second one. Okay, the first one to second one, how much variation. Now, as one of the student has asked me the question of, sir, what is the importance? Can you tell me one practical application of this, where we are going to use the covariance? See, as for example, you are working on a project called as cars data set. Okay, there you are having with respect to the mileage and speed. Now, speed increases, mileage decreases, as everyone knows this one. How much variation between them? This much. If you increase slightly 10, for example, you are moving on a bike of 100 kilometers per hour. Now from 100 to, if you are moving to 110, okay, at 100 kilometers per hour, or let us take a simple example, you are going at 40 kilometers per hour. At that time, you are getting a bike mileage of 40 kilometers per hour is your speed, bike speed. And based on this, you are going to get a mileage of around 48. Okay, 48 kilometers range per liter you are getting, assume. Now, if you increase this one to 60 kilometers, means how much you have increased your speed? 20 kilometers you have increased the speed. Now, how much the mileage will be dropped in that? With this increase 20, here deviation was changed to 20. In that deviation, it will fall now. How much it will fall? How much it will fall? The variance will be there now. Here the variance is this much deviation. There how much is going to be the deviation? That is the covariance. Sir, how you can say it will only fall, sir? It may increase now. For example, this example we know For other examples, how we can know means the sign is there now, positive sign and negative sign. This sign indicates if it is negative sign means they are inversely proportional to each other. If it is positive sign means they are directly proportional to each other. Now, let us take an example. X of 1, 2, 3, 4, 5. Y is equal to 6, 7, instead of 6, 7, 8, 9, 10. Okay. 6, 7, 8, 9, 10. This is example number 1. Example number 2. 1, 2, 3, 4, 5. 10, 9, 8, 7, 6. For this you calculate the covariance. For this also you calculate the covariance. Clearly it is visible now. As X increases, Y increases. It is clearly visible for you. In this example, example number 2, as X increases, Y decreases. That is also clearly visible for you. Now just calculate the covariance. For this one also you calculate the covariance. Answer will be the same except sign. Okay, try. I will take time. 1 minute. Calculate the covariance now. For example 1 and example 2, calculate the covariance now. Only covariance. No need to calculate variance and anything. Only covariance. Now. Just 2 minutes of time. Yeah, what is the answer of first one? For the first example. Zero na. For the first example. X minus X bar minus 2 minus 1 0 1 2. Y minus Y bar, that is also minus 2 minus 1 0 1 2. X minus X bar into Y minus Y bar will be 4 1 0 1 4. Total is 10. 10 divided by 4, 2.5. Why it will be 0? Why it will be 0? For the second one, X minus X bar, again minus 2 minus 1 0 1 2. Third, next Y minus Y bar, which is 10 minus 8, 2 1 0 minus 1 minus 2. X minus X bar into Y minus Y bar. Minus 4 minus 1 0 minus 1 minus 2. Total is minus 10 divided by 4, which is minus 2.5. Guys, it is less than 1 minute. Still you are doing one is plus 2.5, one is minus 2.5. Why it is taking this much of time? X bar is 3, Y bar is 8 now. I have given silly question only now. So what is the difference between these two means? Just a sign is the difference, because the values are almost same now. As here one value is increasing, here one value is decreasing. For every 1 value, 1 value is increasing here. For every 1 value, 1 value is decreasing. So that is the reason variance is same. But sign is different. Here it is increasing, here it is decreasing. Since it is increasing, as X increases 1, Y also increased 1, which was given by positive sign. Here X increased 1, Y decreased 1, it is giving as a negative sign. Now, how much it is decreasing means calculate your variance also. Variance value also will be 2.5 only. So it is decreasing with respect to how much variance is there of one variable to another variable. Is the point is clear now? Next one is called as correlation. Yes. Yes. Okay. So here, just you are going to calculate in terms of the covariance. Covariance is nothing but the variance of one variable to another variable. How much the impact on the second variable is there on the based on the first variable. Okay. Just the same thing which I am applying in my analysis every day. Every day I will use the covariance and correlation during my whatever the stock market, whatever I do, the things for that purpose I'm going to use the same thing. So as you that one again it is irrelevant. Now coming to the next point is called as correlation. Now what is correlation? Means the relation between two variables, how much they are related. How much two variables are related to each other is called as correlation. Okay, how much they are related to each other. So the formula of correlation is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. Now before moving to the correlation, here one point to be noted is population covariance is different. For population covariance, what is the formula? Means x minus mu of x into y minus mu of y. For that you are going to do the sum divided by caps lock n. If you divide by n minus 1, see numerator will not have any difference. Earlier example also, your value will be the same. What are the example you have written in the earlier example? Denominator only you are going to change. Instead of 5, instead of divide by 4, you have to take the 5. You should not take the 4. This is the population covariance formula. Sample covariance formula is x minus x bar into y minus y bar. First you are going to calculate this one. You are going to do the sum divided by n minus 1. This is sample covariance. Sir, numerator will change, miss? No, numerator will not change because whether it is population mean or sample mean, value is same only now. For example, if you calculate for x and y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For this example, if you calculate x minus x bar into y minus y bar, or if you calculate mu of x, answer will be the same. Total we are going to get in the numerator 10 only. Numerator will not change. Denominator, what are the denominator is n? N minus 1 divided by n. That is the question. Numerator is not having any difference. Is the point is clear? Right? Is your question is clear? One of the student from online. Right? Is your question is clear? Shrikant. It is not compulsory. For population data, population covariance. For sample data, sample covariance, we have to calculate. Now coming to the correlation. Correlation is nothing but covariance of x comma y divided by standard deviation of x into standard deviation of y. Okay. Now covariance formula is sigma of, let us take for the sample or population. There is no difference. Population correlation, sample correlation, both are same. Why? That is one which we are going to see now. Sigma of x minus x bar into y minus y bar divided by n minus 1. That is covariance formula. Divided by square root of sigma of x minus x bar in divided by n minus 1 into square root of sigma of y minus y bar divided by n minus 1. Now if you calculate here, this square root will be applied on the both of them. Okay, this square root whatever you are having for the numerator, denominator. Now in the denominator I am having the like square root of n minus 1 into square root of n minus 1. Can I write as n minus 1? So the denominator will be modified to, numerator will be as it is, denominator to n minus 1. This n minus 1, this n minus 1 cancels. Means in your entire formula, n only not there. If n only not there means whether it is sample also same, whether it is population also same. What is the difference between population and sample means n minus 1 only is the difference. So sigma of x minus x bar into y minus y bar divided by square root of sigma of x minus x bar whole square into square root of sigma of y minus y bar whole square. That is the formula of correlation. And the correlation is given by R. Correlation is given by the symbol R. Sir, what about the covariance? Covariance, no symbol, COV. We have to write COV of x comma y. For correlation, we have to write R of x comma y. R with suffix of x comma y. R with suffix of x comma y, it gives the correlation. Now, sir, in this both of them, one point is common. What is that point is? Sign. Sign is there now. Positive sign, negative sign. Positive sign indicates that both are directly proportional to each other. Negative sign indicates both are inversely proportional to each other. Okay? Positive sign indicates both are directly proportional to each other. Negative sign indicates both are inversely proportional to each other. Now, along with the sign, side value will be there now, right? So after that sign, one value will be there now. That value is important in the correlation. Value also having the importance. It tells about how much strong they are having the relation. How much strong they are having the relation. That tells about the correlation. How much strongness in their relation. Okay. If more the correlation, higher the correlation, the analysis will be easy. The lower the correlation, the analysis will be difficult. For example, in this class, one student, let us take two students are there. Student 1, student 2. First student is present on the first day. Second day, same on the same day, first this student also present. One more time. One day this student is absent. On the same day, this student is also absent. Again, present, 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 absent, 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 absent. Now, what is the correlation between them is? They are 100% correlated. Percentage. See, any difference is there? Out of 10 records, total 10 days if I consider, for example, if I take total 10, 1, 2, 3, 4, 5, 6, 10 records. Out of 10, 10 of them as it is same. One day the student is present means same that student also present. One day the student is absent means same day that student is also absent. Now what is the correlation between them is 100% they are correlated. Now 100% when they are correlated, next day when student 1 is present, now tell me whether student 2 will present or not. Blindly we can say student 2 also will come. Easy to analyze, easy to predict. When the higher the correlation, the next one is very easy. For example, some days this person is present, some days this person is absent. Correlation is not there. They are not having any correlation. Can you say that based on one student present, can you predict on the second student miss? No. He may come, he may not come. Who knows? We say like this. Because they are not having any correlation. When they are having the high correlation, prediction will be very easy. When the correlation is less, the prediction will be less. Now correlation means it tells us how much percent two variables are related to each other. How much percentage two variables are related to each other. Okay. How much percentage two variables are related to each other. It gives about the correlation. It gives the correlation. How much percentage they are related to each other. If they are having the strong correlation, analysis will be easy. If they are having less correlation, analysis will be less. Okay. Now, so these are the two correlation and percentage. I told you percentage. What is meant by percent? What is the maximum percentage you will get? Miss 100. What is the minimum percentage? Miss 0. So values will be 0 to 100%. 100% means number is 1. Now value wise 1. So what is the range of correlation means? Positive correlation can be from 0 to 1. At the same time, negative also, opposite side. Opposite side, for example, I am going to say you guys are highly correlated, but in the negative direction. That is minus 100%. So minus 1 to plus 1 is the range of correlation. Okay, minus 1 to plus 1 is the range of correlation. Is the point is clear? The range of correlation, because why 1 only? Because maximum is 100%. 100% is value wise, if you say it is 1. Value wise it is 1. How, sir? Percent means what is the meaning of percent? Divide by 100. What is the maximum probability? 1. Means probability or percentage or anything which is 1. So what is the range of correlation means? It lies between, the range of correlation lies between minus 1 to plus 1. The range of covariance is minus infinity to plus infinity. But it is minus 1 to plus 1. In the correlation, the value is also important and the sign. Now, higher the correlation, the greater the correlation, higher the value, they are close to, the data points are very close to each other. Okay. And so based on this, if the correlation is equal to 1, they are perfect correlated. When it is perfect correlated, your prediction will be 100% more accurate. Okay. Exactly it is equal to 1 means it is called as perfect correlation. Perfect. Okay. Let us take like this. Example. X is equal to 1, 2, 3, 4, 5. Y is equal to 6, 7, 8, 9, 10. Now, if you observe, the correlation between them will be, after calculating, you are going to get 1. Perfect correlation. Now, for 6, what would be the value? What would be the value of for 6 here? If I take on the x-axis 6 means, what is the y value would be miss 11. Simply you are going to say 11. How? Very simple. Y is equal to x plus 5. Every y value is equal to x plus 5. So here every 1 value are increasing. Here also 1 value will be increased. So here 1 value increase means here also 1 value will increase, and you are going to get the 11. Right? Easily you can predict. For example, here 15 is there. Now tell me, if it is 15, can you say here what is the exact number? Relation is not that much of perfect now. If I ask the question, what is 1, 4, 9, 16, next number, what is the next number? If I give like this, automatically you will say that next number is going to be 25. Because 1 square, 2 square, 3 square, that basic things you will apply. Now, if I say 1, 4, 8, 12, 6, 14, what is the next number, miss? Sir, what is this, sir? One time you are adding 3, followed by 4, followed by 4, again you added only 2. From where I have to get the exact answer? Exact answer cannot be predicted because exact relation is not there. Still we can predict. I'm saying that still we can predict. Here also we can predict, but not with 100% accuracy. Accuracy may not be 100% because data is not 100% pure data, right? So in that way, so here correlation we are calculating. How to calculate the correlation means, if you go back, once you go back to your example earlier, first example in the today's class, we have discussed x and y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 15. This is the one. Can you open that example once? In that example, first you calculated variance of x. What is the variance of x? 2.5. So now what is the standard deviation of x? Automatically it is going to be the square root of 2.5. Next, variance of y. What is the variance of y? 12.5. If you calculate the standard deviation, it is going to be the standard deviation is equal to square root of 12.5. Next, covariance of x comma y. What is the covariance of x comma y? 5. So now correlation of x comma y is equal to 5 divided by square root of 2.5 into square root of 12.5. This is going to be the correlation for the given data set. Already you calculated all the values, just you are substituting them for the same data set. Now, what is the value you calculate? What is the value, miss? So here I'm going to calculate in terms of first the square root of 2.5. That is 2.5 into power 2. Okay, into similarly for 12.5 also power 2. Power 1, sorry, power 0.5. Power 1 by 2, which is 0.5. Square root means power 1.5. So which is 5.59. I'm dividing with the 5. 5 divided by this one is nothing but 0.89 is the correlation. Okay, is the point is clear? Now let us cross check. Okay, 0.89 which I have got here after applying this max. This one is clear now for everyone. 0.89. Now since I'm having the two variables with me, only two variables, this is x and y, this is also x and y. What is this? Is the variance correlation of x comma x. This is the correlation of x comma y. This is the correlation of y comma x. This is the correlation of y comma y. Now first let us start with the correlation of x comma x, which is sigma of x minus x bar into again x minus x bar divided by square root of x minus x bar whole square into square root of x minus x bar whole square, which is x minus x bar whole square is the numerator. Denominator square root will be square root if you multiply, which is nothing but sigma of x minus x bar whole square. Cancel means you are going to get 1. So what is the relation to the same variable means? It is going to be 1 always. Now what is the correlation of y comma y? That is also going to be 1. And this is 0.89. And what about this one? If you multiply that one to this one to that one, also answer is same only now. So this is also 0.89. So you are going to get the values in this way. Is the point is clear for everyone? So what is the difference between the covariance matrix versus correlation matrix? Means diagonal values in the covariance matrix. Within the covariance matrix, the diagonal values will be there now. What are the diagonal values are there? It is going to be variance of x, variance of y, variance of z, like this. And in the correlation matrix, the diagonal values will be always 1. Here diagonal values will be 1. Here it is going to be variance of x, variance of y, and variance of z. Here the values are covariance of x comma y. This is correlation of x comma y. This the upper triangle matrix and lower triangle matrix will be the same in the both the cases. It is going to be the symmetrical matrix always, where upper matrix and lower matrix will be the same. Is the points are clear? Now coming to the next one, bivariate measures completed. Now multivariate measures. Now what is meant by multivariate measures means there is nothing like multivariate measures. We are also same thing we are having covariance and correlation only, but in terms of matrix. There is at a time 3 variables we can't consider and we can't apply any kind of measure on that. So always we have to consider two columns and we have to apply the measure on that, which is matrix, covariance matrix and correlation matrix. For example, if you are having 5 columns, for 5 columns you have to calculate the covariance means at a time can you apply on 5 columns means no. By taking any 2 columns you are going to apply the matrix. Is the point is clear? Now if I have to explain for this practical example which I am doing in the stock market and I am making the profits based on this only 2. One is covariance and correlation. Now whatever the in the stock, as I have told you, in the stock market I will do investment, at the same time I will do the trading. Trading means buying and selling in a short period of time. I will buy today, I may sell tomorrow or day after tomorrow or 10 days or 15 days, but within a short period of time I will sell. One is called as investment. Investment means I'll keep today and I'll keep for 6 months, 10 years, 5 years, like that. Okay, I will do both of them. Okay, that one I will do, this one also I will do. Okay, now whatever I'm doing on the trading, here whatever the trading I'm applying now, here I have identified one logic called as paid trading. This is the strategy which was developed purely by me. Okay, by me, for me. Both of them only for, it is developed by me and it is only for me only. I only developed, I only back tested, I only cross checked, I only applying, I am only making the profits. If I only get the loss also, I am only going to make. If everything goes positive means later it will be not something. But as of now, it is in the testing phase for me. How many days you will test on means 3 years to 5 years minimum. Okay, it has to be tested at least for 3 to 5 years in the real time. Then only we can release into the market and we can do some business based on this. But till that we can't do, because see, during some people will say, today if you say, sir, buy this stock. Okay, now Narendra Modi announced any something related to that one means suddenly your stock will increase means you say that, so no sir, I have told you no sir, this stock will increase now. We'll take the credit. But suddenly anything news has came opposite way, it falls means, don't worry, it will rise. Wait. Some people will say like this. So when they go positive means they'll take the credit that I only have told, I only have done this one like that. When it goes in the negative direction, they'll say that wait. Before to that, they will say in 10 days only everything will happen. Now everything goes wrong means, don't worry, in next 1 month, 2 months you'll get the money. Suddenly they'll change that one. Right? So these are the different types in the market, different things will be there. Recently, one of my friend only has told me this one. I'm doing the trading from so many years and having experience. He has entered into the stock market recently. Okay, maybe just less than 1 year. Recently in the stock market, he has invested some money related to railway stocks and defense stocks. And suddenly it was raised. One day he has called me. Arey, sir, I told you, Nara. I told you, na. It will increase. It will increase. It will increase, na. It has increased. See, have you seen this much of profit? And he has told that one company name called as Heritage. He told that Chandrababu comes into the power in Andhra Pradesh means 100% this company will rise. And see this one. Really, it has raised. Okay, everything was done. He is depending on the news present as of now. What are the news and trending is going on in the outside market? Now, recently, last 1 month onwards, market has started falling. Now, market has fallen more than 10% to 15%, and many people has got the loss of 20%. And October month is the worst month for every person as investor. Now, at that time, I have called. Just I asked, how is yours? Very bad. But I'm sure this is very good stock. It will increase. He has to cover himself now. Now, yesterday only he has called me. SRK, I'm getting 20,000 loss. Now what I have to do? He started asking like this. He has invested 1 lakh rupees and he has got 28,000 loss it seems. And he has called me and he asked, now what I have to do? You told now, wait, continue. So when you're going with the as per the market trend, the trend might be applicable for that time, but it is not the right one. Booming time, IT when it is booming, jobs will be very high. At that time, what are the jobs, what are the course outside people will say, everyone will get the jobs. But when the market is in the downfall now, at that time getting the job is more important. In the market is very high in the IT industry and every Lilliput course if you do also you'll get the jobs. At that time if you do means, what are your friend has suggested? Your friend says that I only told na. He will say like this. Now market is down now. Now you tell me which course you have to do, where I have to do or what I have to do. Now you tell me. This is the right time. Now you tell me. And particularly in the December month, we know that jobs will be very low because as per the US, this is completely weak, year end for them. And no fresh jobs will be there in the December month in the US. Out of the entire year, the lowest jobs, new jobs will be in the month of December. Again in the February, maximum number of jobs. February, March, maximum number of jobs. Now in the December, tell me what I have to do. Now none of the person will respond. Only experienced people now they will respond. Because they have seen all these cycles in the past years. Now the same way, why I have told all these things means, I have applying the paid trading strategy, which was derived by me only. Now this one, what is the meaning of this paid trading is, I will buy one company. I will buy one company. At the same time, I will sell one company. I will buy, at the same time, I will sell. One company stock I will buy, one company stock I will sell. Okay. For example, I'm going to purchase the HDFC Bank and I'm going to sell in terms of Kotak Bank. Or I will, sorry, in today's 1 minute, let me check my positions, which I have taken. It might be negative or it might be positive, guys. I'm not saying that I will 100% get everything positive, but accuracy is comparatively high. I'm not saying 100% accuracy. So as of now, it is showing some kind of 7,000, but you can see here clearly Kotak Bank, which is of plus 2,800 shares are there for me. In the HDFC Bank, minus 2,750 shares are there. 1 rupee increase in the Kotak Bank will give me 2,800 rupees. 1 rupee increase in the HDFC Bank will give for me minus 2,750 rupees loss. Okay, this is the one. Now, based on this strategy, what are the strategy I have developed? Now, in this strategy, what happens means I'm going to buy the Kotak Bank now, and I'm selling the HDFC Bank. Now, the question is very simple. Why you have selected only these two banks? Only these two banks are there. ICICI is there, SBI is there, Axis is there, RBL Bank is there. Like this, multiple banks are there. Why you selected these two only is the first question. Second question, how you know these two only you have to sell it at this rate? Means every time it is applicable? No. At particular one point of time it is applicable. How it is calculated means based on the correlation. These both are having the correlation high. What is correlation high means? What is the meaning? One is both the having the higher correlation. One is increasing means other also increases. One is decreasing means others also will decrease. These both are having the high correlation. So now today Kotak Bank increases means HDFC Bank also increases, or HDFC Bank falls means Kotak Bank also will fall. But in between them, gap will be there now. For example, Kotak Bank was increased 10 rupees. 10 rupees it has increased. But HDFC Bank was increased to 8 rupees only. Increased, but 8 rupees. What is the correlation between them now? 80% is the correlation. For 80% correlation, for every 10 rupees increase in the Kotak Bank, how much HDFC Bank has to increase? 8 rupees has to increase. Now, Kotak Bank has increased 10 rupees means 10 into 2,800, which is 28,000 profit I am going to get. 8 rupees into 2,800 is the loss. Let us take 2,800 of this one also. So balance, what are the 2 rupees net profit is there now? 2 into 2,800, which is 5,600 is my profit. Example I have shown for 2 rupees. Sir, what is the exact number? Don't ask, I will not reveal. Okay, example purpose. Now, how you calculated this one? Covariance. How much variance is there? How much correlation is there? I can take any other 2 banks also, but they're not having that much of high correlation as these two. Correlation should be there. At the same time, variance also should be calculated. Based on my statistics analysis, I have done and I have applied this one. And from last 1 year, I'm doing the same. This financial year, I'm doing only paid trading. I'll be in the regular class, in your class time. I will not even check what is the value and everything, as I told you earlier. So I will never check what is the value. Just I will ignore this one. See, 18,000, 19,000. Okay, enjoy. Leave it. Okay, it increases or it decreases. Whatever happens. Okay. And next, first when I have opened, it is 6,000 in front of you. Now itself in the gap of 12,000, I have made the profit. Okay, that is common. You might get at the same time profit, at the same time loss also. Don't think I will get always profit. Yesterday I got 1 lakh rupees loss. Okay, 1 lakh rupees loss. So sometimes I am going to check, see, out of 100 times what I execute, 100 times I apply this strategy on different stocks. 100 times if I execute, out of this 90 times it will be the success, 10 times it will be loss. 90 times into each time if I get 10,000 rupees profit also, 90 into 10,000 is 9 lakhs. If I get 10 times loss also 10,000, 1 lakh is the loss. So net profit is going to be 8,000 for me. I mean, sorry, 8 lakhs is going to be the profit for me. I'm not saying that 100 out of 100 every time it will work. Loss also I will get, but my accuracy is comparatively high. Why? Because of my statistical analysis with back testing. I will cross check. For example, the same logic I have applied 8 months back. Randomly you select one date. Randomly you select one date. On that date you have applied this strategy only. Whether it has worked or not, I'll cross check myself. That is called as cross validation. Cross validation. Okay. Randomly you select any date of your choice. And that date it will satisfy. And if it is satisfying that particular date and from there the strategy is working, means today also it will work. Because you are selecting randomly, you are not doing the bias in sampling now. Random sampling, right? Not only take one date, take at least 5, 10. 10 dates you select as per your choice. Out of 10 dates, 9 of them are working and one is not working, means also 90% accuracy is there, right? If 90% accuracy is there, then why I can't take the risk? When accuracy is high and I'm able to get the profit, I'm going to take the risk for that. Is the point is clear? Here, what is the strategy I have applied? You know, only two. One is called as correlation. Second one is called as covariance. In these two only, I am making every month 1 lakh rupees profit. Only two formulas. Okay. But how you have to apply that one only project? You have to apply the logics and you have to do the data analysis. Once we enter into the data analysis, you'll understand that later. Okay. I can't exactly reveal the secret of that, but I can explain for you the how you can apply the logics like that. I have applied multiple logics. This is one of them which is having the high accuracy. Another logic back testing was failed. One logic, one person will have. You'll have one logic. You'll say like this, sir, today news, Narendra Modi is saying this one, sir. So most probably defense stocks will increase. Or outside Ukraine war is there, no, sir. It is going to increase the war level and defense chemical stocks will increase. Something you are saying. Same way, when the war was, now this is the year of 2024. Somewhere in the another year, somewhere war will be there, na? Either in the 2000 or 2002 or 2003, somewhere war will be there, na? At that time, whether as per your logic, whether it has worked or not, we have to cross check that one. Today you are saying based on the war, this company's share price will increase. Now similarly in the 2000 also, 2002 also, 2003 also, war was there, na? Not Russia-Ukraine war. Some other war will be there, na? If the similar kind of war is there, sir, similar kind of wars are different, sir. Russia-Ukraine war is different, sir, because these are the two big countries. No two big countries has fought earlier. No war is there. 1990 or 1987 or 1990. At that time, the stock prices are very small, sir. I'm not considering stock price. I'm considering the difference there between them. Percentage. How much percentage was increased? From 100 rupees, it has went to 200 rupees. Double. Same way, if today the stock price is 1500, double means 3000 now. There, how much percentage I'm seeing? I'm not saying the numbers, the percentage difference. And in that way, we are going to do the calculations. These are called as statistical analysis. If you are using only statistics and you are analyzing the data, and not only me, the entire stock market will depend on the stock market, which majorly depends on the statistical analysis of for investments for so many purposes. Even if I have to show you one more example, okay. I'm taking the example only from, don't ask the question why you are considering only the example from stock market, because other examples you have to see is we have to enter into the data sets. Even this one also you're not familiar, but just as an experience, since it is available, the data output also available, I'm showing for you. Okay. 1 minute. So here, this is one of the website, and this website they have given us in terms of what values, what are the values are there. It is giving that values. It is showing the importance of with respect to how the it is correlated to the Nifty. Nifty means stock market, main one. So that is correlation. Based on the correlation, if the correlation is very high, our analysis will be very easy. Remember this, right? Now coming to the second one called as next topic, central limit theorem. Okay, let us continue with the next topic, central limit theorem. Now what is central limit theorem? Why they have invented central limit theorem? What is the purpose of CLT? The central limit theorem is very simple. Okay, here the central limit theorem is what are the probabilities there? Probability of a single value is always 0. Why, sir? Because, for example, if I have given, if I'm asking you what would be the today's temperature, I have given you the last 10 days temperature for you. Last 10 days temperature I have given, and I'm asking what is the today's temperature. Now what you are going to calculate means average value. So from this, since you have given the 10 days, I'm calculating the average. Now you have told that today's temperature would be around 28 degrees at 1 o'clock. Let us take the time at 1 o'clock. Every day you have collected the degrees at exactly at 1 o'clock. You have collected the temperature and you have applied today the thing. Now what is the probability being today temperature exactly 28 degrees? Exactly 28 degrees. How many records will satisfy that one means? One record. Out of how many records? Infinite number of records. 28.1 is there, 28.12 is there, 28.01 is there, 28.42 is there. Like this, infinite number of records are there. Out of infinite, your value is one of the value. 1 out of infinity. So here the what is the probability of a single value means it is going to be 0. So always the probability of any for a continuous variable, the probability of a single value is 0. So never we have to predict with a single value. For example, if I ask you the question, what would be the salary? What is the estimated salary based on the skills? Sir, how much salary we can expect? For example, 5 lakhs. 5 lakhs means what is the probability of getting 5 lakhs means 0. Exactly getting the 5 lakhs 0. For example, if the person gets 5 lakhs 20,000, you have correctly predicted or wrongly predicted means wrong only because you told 5 lakhs only now. Sir, 5 lakhs 20,000 means plus. Okay, no, sir. Almost close, no, sir. Almost close means you can predict that one only now. You can say 5 lakhs plus or minus 50,000. Then if it is exactly 5 lakhs 20,000 also, it is correct prediction only. Why you are saying single number? Instead of single number, predict with a interval. Always predict with a interval. Don't predict with a single value. If any person asks you, if for example your friend has purchased one used car, second hand car. First hand car means automatically it is a fixed price. You don't need to predict for that. Right? For second hand car, your friend has purchased one second hand car and he asked, what would be the cost, what would be the price of this car means? You are going to say, I'm estimating 8 lakhs. What is the probability of 8 lakhs means 0. You should never predict with a single value. You have to say with, I'm assuming 7 to 9 lakhs. 8 lakhs plus or minus 1 lakh. 7 to 9 lakhs. Then if he have purchased exactly at 8 lakhs also, 8 lakhs 10,000 also, 8 lakhs 20,000 also, your prediction will be within the range. So here, since the probability of continuous variable for a single value is 0, always we have to calculate the probability for a interval. For a probability for an interval will be there. Yesterday you calculated for 50 to 60, 60 to 70. How many values are less than 70? Less than 70 means from starting to 70. Have you calculated anywhere for a single value in the yesterday's class? X less than 70 you calculated, X greater than 70 you calculated, X is equal to 70, have you applied? Single value, the probability will be 0. For a given date, unless the data set was given to us. If the data set was given and numbers are visible directly, what is the probability of this number means how many number of records are there with that number divided by total number of records. That is direct. When the records are given, then it is not applicable. Then only the formula of probability is applicable. When the records are not given, okay, temperatures are there, you are going to calculate average temperature. Average temperature will not be in the inside the data now. That data, you know, today what would be the data at exactly at 1 o'clock? What is the temperature at Hyderabad? No, right? That data is not there. When that data is not there, how we can calculate the probability for that one? So we are going to have in terms of interval. How this interval will be calculated means you are going to estimate one single value first. For your estimated value, single value, whatever you have estimated, for that particular value, you are going to take plus or minus some error. Okay, estimated value with plus or minus some error. You are going to take with plus or minus some error. That error you can't take as per your choice. This error should be of standard error. It has to be derived from the standard deviation. You cannot take as per your choice what are the error. For example, if I ask what is the cost of this building, you are going to say, sir, I assume this cost is 2 crores, sir. 2 crores, exactly 2 crores, sir. Plus or minus 10 lakhs. So maybe it might be with plus or minus 10 lakhs of 2 crores. Something you are going to estimate now, that one only. So your estimation is nothing but average value. Always you will estimate average value. For the average value, you will add plus or minus some standard error. And this is going to be x bar minus sigma by square root of n to x bar plus sigma by square root of n. Okay. So basically you are focusing on the center value only. Center limit theorem is center value focusing, but limits means upper and lower limits you are adding. Our requirement is this one only. But instead of saying with a single number, we'll add plus or minus some. Now, if for example, for single number, what is the probability means 0. For the interval, what is the probability means sometime probability will be there. At least something, 1% or 2% probability at least will be there. Interval will have probability. Single value will never have the probability. Okay, I'm not saying this interval, what are the interval you are taking 100%, it is not in that interval. It is having some probability, at least some probability is associated. In the earlier case, probability is not there. Now, sir, I want to estimate with, you are saying any probability now. I don't want any probability. I want exactly 90% probability. Can we estimate with 90% probability? Can we estimate with 80% probability like that means? Yes. That is only next concept called as confidence interval. With the confidence interval, we are going to get the output. See, here, first we are calculating the interval. From interval, you are calculating the probability. So yesterday, do you remember from Z-score how to calculate probability? Similarly, from the probability, can you calculate a Z-score? Same way, I will give the probability. I will give you the probability, and I'm asking based on this probability, give me the interval. This is input means this is going to be the output. If I give the input as probability means you have to give me the output as interval. Today, what would be the temperature? Predict with a 90% probability. Take interval of your choice. If you want, I will tell one example like this. Today, exact at 1 o'clock, the temperature will be with 100% probability. It is going to be between 0 to 60 degrees. 0 to 60. You didn't told the interval size is this much only now. You are asking me probability. With 100% probability, I am predicting 0 to 60. Sir, 0 to instead of 0 to 60, you can take 0 to 100 also now. 200 also now. Tell me with a proper range, sir. Don't tell with a normal numbers like that. Lilliput also will tell that one. 0 to 60. Today temperature will be 0 to 60. Lilliput also will tell. What is the special of use? Means here I am going to predict with higher probability with a small range. Okay. My range will be small. I'm not going to take a big size of range. With a small range, with a high probability, I'm going to predict. That will be happened by using the confidence interval. Now, how it is possible means very simple. In your central limit theorem, x minus sigma by square root of n, comma, x plus sigma by square root of n, right? This is the one. Now, this is central limit theorem. Now, for confidence interval, what we are going to do is x bar minus, instead of considering sigma by n, we are going to consider z value. I'm going to multiply with the z value. What z value? With what probability you want? 90% probability means for 90%, what is the z value? That value I'll multiply. If you want 95% probability means for 95% probability, what is the z value? That one I'll multiply. Yesterday I have told you how to calculate probability at 0.9. If the probability was given 0.9, what is the corresponding z score? Do you remember that one? If your requirement is 90% probability, tell me what is the z score and multiply with that. If yours is 95% probability, tell me the z score at 95% and substitute that. Along with this, x bar plus z of sigma by n. You have to multiply with z. Z value you have to multiply. Only difference is this. Now, with this interval, exactly you'll get 95% is the answer. How, sir? We'll try with a small example. By taking any 10 records or 5 records, and let us calculate first interval. After that, we'll calculate for with z score also. Again, after substituting the z score, we'll get one interval now. Without z score, with the g score, we'll calculate. Without g score, you'll get any probability. With the g scores, you'll get exactly the same number of 0.95. How it is possible means by taking one example, you'll understand. So that example will continue in the tomorrow's class. And from there, inferential statistics, because this confidence interval is directly related to your inferential statistics. One test. Okay, z test is there. That z test and this one are correlated to each other. That you'll understand in the tomorrow's class. Is the point is clear? Everyone? Anyone has any questions? Where? Polestar. Poster. In terms of you are asking exit poll survey type. Exit poll, not confidence interval, right? That is inference statistics. That is tomorrow's class. That is here numbers. Again, it is applicable only on the continuous variable. Continuous variable. Right? Now you are trying to apply on the count variable. It is not going to apply on the count variable. It is only on the continuous variable. Is the point is clear? So you can estimate the mileage of the bike. So mileage of the bike plus or minus. If anyone says that, how much mileage you are getting, miss 45 kilometers, exactly 45. Yeah? You may get 46, you may get 44, you may get 44.4, anything now. So plus or minus. So for continuous variables, we are going to apply the central limit theorem and confidence interval. Right? Yeah. Anyone has any questions? Guys, if anyone has any questions, you can ask. What are the questions you are having? Sir, I have fixed the interval size, maximum, minimum, and calculated the number of bins. Now I am getting it to decimal. In this case, how to consider the number of bins. So, according to the bins, if you want the number of bins means you have to change the interval. For the bins, you have to change the interval. You can't fix the interval, any one. That one, for example, you are getting the bins as decimal value, which is not possible. So you have to take 5 bins means according to that interval also will change. Maximum value, minimum value will be fixed. That none of the person can change because for the given data, maximum and minimum is fixed. But interval size is you have fixed now. Now you have to change that interval size because you are not going to get the bins of like that. Is the point is clear? Chetan. But still, you want the same interval size. In that interval size is only what numbers are there. That one only you want means that you can see in the matplotlib. I'll show you in the matplotlib there is a code. I can show you that one and you can apply that. Just wait for another 2 days. In the matplotlib you'll see this in the next week. Right? Copy this question in a notepad and keep the question as it is like that. Done? Yeah, others you can leave. If you're not having any questions, you can leave.